For this video, I will be writing down the problem, and then after I solve it, I'm going to put a practice problem so you can solve it on your own. Determine for each number whether it is a rational or irrational number. So remember from the previous video that a rational number is one that can be expressed as a product of ratios, a quotient, a fraction. Okay. We didn't talk about positive or negative, just said you can represent it as a quotient or a fraction. Now, the first one is negative 1/3. Since it is a fraction, then we know that it's a rational number. So we know that this is rational. Now the second one is the square root of 5 divided by 10. The square roots are rational numbers only if they are perfect squares. In this case, 5 is not a perfect square, therefore this is an irrational number. The next one is 5 divided by 7. Again, that is a ratio, so we know that that is a rational number. And lastly, we have 2 times pi over 3. Now remember that pi is an irrational number. So if pi is an irrational number, the product or the quotient that includes pi is going to be an irrational number. So whenever you see pi, you already know that that's an irrational number. Now, do the 4 examples. For this part, you're going to determine whether the following comparisons are true or false. For the first one is the square root of 7 is less than 2.95. You need to determine whether that's true or false. So the first thing you need to do is find out the approximation of the square root of 7. Since the square root of 7 is not a perfect square, we need to use a method that we practice in class. Find the perfect squares right below and above square root of 7, which is going to be square root of 4 and the square root of 9. Now you know that your answer is going to be somewhere between 2 and 3, so it's actually close to 2.95, but now let's see if it's larger or smaller. So to do that, we are going to find the difference between 4 and 7, which is 3. So you write down 3, and then you find the difference between 4 and 9, which is 5. So you know that your answer should be somewhere around 2 and 3 over 5, which is actually 2.6 if you follow long division. Now, is this less than 2.95? Yes, that is true. And that is the first answer. Now, you need to try one yourself. Now the following one is a more complex one. You have the square root of 35 divided by 6 is less than 8 over 6. For this problem, you don't actually have to divide a by 6 to figure out your answer. The only thing that you need to pay attention to is whether your numerator is actually less than 8. So you need to find the square root of 35. We are actually only going to approximate. Remember that the square root of 35 is going to be between the perfect squares, which are 25 and 36. So you know that your answer is going to be somewhere between 5 and 6. So the square root of 35 is not actually going to be larger than 6. And since it's not going to be larger than 6, we know that the most it can be is 6 over 6. And the other one is going to be 8 over 6. So you know that the left side is greater. So this one is going to be true. Approximate the square root of the following expression. So we need to find the square root of 45 plus 13 minus 4. Before we even find the square root of that, the first thing that we need to do is combine like terms. In this case, we have only integers, so we are going to only add them. So we are going to start by doing 45 plus 13, which gives you 58 minus 4, and that will give you 54. Now we know that this is not a perfect square, so we need to find the method of approximation that I taught you. So we are going to find the perfect square right above and below 54, which is going to be 49, and also so we know that your answer is going to be somewhere between 7 and 8. And now the difference between 49 and 54 is going to be 5. And the difference between 49 and 64, that is 15. So you know that our answer is going to be somewhere around 7, 5 over 15. So it should be somewhere around 7.3.